today we're going to be reviewing what's called the rational root theorem. And the first question you're probably going to have is what is the value of p mean and what is the value of q? All right. What you guys need to understand that we're going to look for the factors of p, and we're going to look for the factors of q. And then we're going to look at all the possible roots that can go into this and make this equation equal to a 0. All right? Now, the factors of p are pretty easy. What are the factors of this number 3? Just 1 and 3. So we've got 1 and 3. And the factors of the q value are simply just 1 and 2. All right? Now, when you look at this 1 and this 3 and this 1 and this 2, what you have to do is think about what are all the possible numbers that we could come up with using these factors divided by these factors. So here's what I'm going to start with. I'm going to start with 1 over 1. So I'm going to put 1 over 1 is just a 1. Then I'm going to say 1 over a 2. I'm going to write 1 over 2. So right now, those are the only two numbers I can make with 1 over 1 and 1 over 2. Then I'm going to move over to the 3. And I'm going to write what? 3 over a 1 and 3 over a 2. What you need to understand is these can be positive or they can be negative. So if we wanted to list these numbers from least to greatest, we could say plus or minus 1 over 2, plus or minus 1, plus or minus 3 over 2, and plus or minus a 3. Now, what I need you guys to understand is this right here represents what's known as all the possible roots. This is the answer if it asks you the question, what are all the possible roots that could go into this long polynomial? All right? Correct. So this is the list. This is the list of all the possible roots for number 2. So on number 2, you're going to write down these as all of the possible roots. The next thing we're going to do is we're going to use these and test to see which ones actually work or which ones don't work. Okay? So just because these are possible doesn't mean all of them will indeed work. Then we're going to use synthetic division to test them. So what I want you guys to do right now is on your separate sheet of paper, we're going to test to see which ones work and which ones do not. So we're going to write a 2. We're going to start with x cubed, x squared, x to the first, x to the 0. So on your paper you have a 2, a negative 3, a negative 2, and a 3. So we're going to write, we have 2x cubed, then we have negative 3x squared, negative 2 x's, and a positive 3 constant at the end. Now, when you guys are checking to see if these work, just start with the easy ones. Start with one that you think might be easy to plug in and test it first. You don't always have to go with the most difficult. So which number here would you guys like to test? A half, a 1, a 3 halves, or a 3? 1. Let's just try 1. We're going to try 1 right here and see how it works. Bring down the 2. 1 times 2 is 2. Add those together, you get a negative 1. Multiply it together, you get a negative 1. Add them together, you get a negative 3. Multiply it together, you get a negative 3. And we get a remainder of what? 0. So luckily, the number 1, if we don't get a remainder of 0, then it is not a root. It does not work. Okay? So this one, because we have a remainder of 0, it works. So what I want you guys to do is you're going to build what's called a solution set. So the very first number I want you to put in that set on your page is the number 1. The number 1 does indeed work. Okay? Now, The 2 here represents the x squareds that we have left. The negative 1 represents the x to the first, and this negative 3 is our constant that we're going to put at the end. So I want you guys to pay close attention to this 2, the negative 1, and the negative 3. So I'm going to go to a new page real quick. All right, go to a new page, and I'm going to write 2, negative 1, and a, did I say negative 3? Negative 3. This represents the x squareds. This represents the x to the first. This represents the x to the zeros. Now we need to test a new number. All right? Now, once again, our possible factors were what? Plus or minus a half, plus or minus a 1, plus or minus 3 halves, and plus or minus a 3. So now that we've figured out one of our answers, remember, one of our answers was indeed the number 1. That's part of our solution set. All right? So for the sake of the video, I'm going to choose one that's incorrect. All right? So I'm going to choose negative 1. Okay? So you don't have to do this on your paper. I'm just going to choose one that's incorrect just for the sake of the video. I'm going to bring down the 2, multiply them together, and get what? Negative 2, add them together and get negative 3, multiply them together, get 3. Oops. I guess I found one, just accidentally. All right? So right here, what did we just find out? We found out another one that actually works because it was a 0. So I guess you should write it down. All right? So we have a 1 and we also have a negative 1. That works. So hey, we're 2 out of 2 right now. Okay? So right here, the 2 represents how many x to the first that we have. The negative 3 represents the constant at the end. By the way, here's how it always works. If you're leading out with an x squared, this number is always going to be your x to the first.
This is just an example, right? Not the actual problem.
No, this is actually problem number 2.
Yeah, but why did you leave out the x cubed?
Okay, hold on. We started out with this one. So we tested one, right? We tested it and it worked, so guess what? Now we have this left.
Okay.
So since we have this left, we get to start with the smaller polynomial. All right? Now we even have a small little binomial. Now, by the way, let's look at this. How many x's do we have?
But would negative 1 go into the actual problem as well?
Correct. If you wanted to start with negative 1, you could have started with negative 1. You would have ended up with a different polynomial, and then you could use 1 and work your way through that one as well.
Wait, I think I did.
Here's what we have left. We have a 2x and a minus 3 left. When you guys get down to the very end, where you just have basically an x and another number, what I want you guys to do is I want you to take whatever you have left, all right, and just set it equal to 0. Once you're down to 1x, not x squared, not x to the third, not x to the fourth, if you're down to just x to the first, set it equal to a 0. And then just solve for what? Y. No, not solve for y. Solve for x. So how would we solve for x on this one? Just simply add a 3 to both sides. And you get 2x equals 3. And then divide both sides by 2. And what's our final? Our final root. Our final solution is a what? 3 over a 2.
I meant y, d, like equal to 0.
Oh.
So what would happen if that ever
The 3 halves? The negative one? Then I want to test another number to see if it works. So let's look at our list. Remember, what does this list up here represent? This list represents all the possible, right? This right here, everybody, these are what's known as your actual roots. Correct. You have 2 answers. You have to list all the possible rational roots. And how do you do that? You take the factors of p over the factors of Q, and you list them out, plus or minus. And then you start using these. Notice, we used a what? A plus or minus one, and which one worked? That one worked right there. And then we actually used what? The positive 3/2, and that actually works as well. So which roots would not work? A plus or minus a half, or a what? Plus or minus 3, or a negative 3/2 wouldn't work. Okay? So right now, what I'm going to do, since plus or minus 3 doesn't work, I'm going to show you that plus or minus 3 doesn't work real quick. All right? So a 2, a negative 3. You don't put this on your paper. I'm just going to show you right now that if I used a 3 right here, even though that was a possible root, it wouldn't work. Bring down the 2, that gets me a 6. Add it together, you get a 3, then you get a 9, a 7, a 21, and that becomes a 24, so you know that that doesn't work out of all of them. Okay? If you use a negative 3, it wouldn't work as well. But the ones that did indeed work, the actual roots, are these right here. So every single answer that you guys do on this assignment, you're going to list all the possible roots and all the actual roots. All right, we have this one is, we're going to go down to number 4. It's not going to take that long for number 4, so I want you guys to go ahead. We're going to do this one together. So let's get number 4 ready to go. All right, we're starting this problem. The very first thing we have to do is we need to highlight 2 numbers. Now, one of them you can't see, even though it's there. There's a 1. What does this number right here represent? What letter? E. And this letter represents Q. And we're going to put plus or minus the factors of P over the factors of Q. Now, what are the factors of 8? A 1, a 2, a 4, and an 8. What are the factors of 1? Just a 1. So what are all the possible factors that could go into this? Or sorry, what are all the possible roots that could go into this? All right, all the possible rational roots are going to be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Remember, these are not the actual roots. These are the possible. All right, so now that we've listed all the possible, now we're going to test them. All right? So we're going to we're going to use synthetic division. We're going to start with x cubed, then go to x squared, then go to x to the first, then x to the 0. So right now we have, how many x cubed do we have? We have 1. We have 3x squared. We have negative 6x's, and we have negative 8 constants there at the end. All right, we're going to test these possible roots. Myra said she found a root. What root did you find? Positive what? 2. Positive. Let's check it. Bring down a 1, multiply it, get 2, add it, get a 5, multiply it, get a 10, add them together, you get 4. 2 times 4 is 8. Myra did find a root because it's 0. That means it works. All right, so one of our roots right now, one of our actual roots that you're going to write down is the number 2. She found an actual root. Now, this is your x squared. This is your x to the first. This is your x to the 0. So now we're going to start the same process, and we're going to list our x squared. So how many do we have? 1. We're going to list our x to the firsts. We're going to list our x to the 0. All right, and we're ready to go to test again. While I pause it, Myra found another one. What's another one? Negative 1. Let's check. Negative 1. Bring down the 1. Multiply it. You get negative 1. Add them together. You get a 4. Multiply it together. You get a negative 4. And once again, Myra is right. It works because it zeroes out. And by the way, this represents your x to the first. This represents your x to the 0. We have x plus a 4. And what did I tell you to set x plus 4 equal to? 0. And what number works? A negative 4. So our final answer is a negative 1, a negative 4, and what was our final one? The very first one? positive 2.